Hello, Geometry. This is Chapter 7, Lesson 5. This is the final lesson in Chapter 7. So after this, we'll start reviewing and getting ready for that next test. This one covers the final, what they refer to as special quadrilaterals, and the two that we're going to cover are trapezoids and kites. So let's go fly kite. So that's what are some of the special properties of trapezoids and kites. We'll look at what we call mid-segments and diagonals and some of the interior angles and some of that stuff. And again, as all trapezoids and kites, the interior angles, as all quadrilaterals, the interior angles will add up to 360. Okay, so a trapezoid. This is what a trapezoid looks like. Let me make it a little bit darker for you. So you notice we have one set of parallel sides, the top and bottom. Okay, when you get two sets of parallel sides, that creates a parallelogram. So one set of parallel sides is referred to as a trapezoid. Okay, we have several different names that we'll write down. This would be referred to as an isosceles trapezoid. You see how the two left and right sides, those are called the legs, those are the same length. So that's an isosceles trapezoid. This would be something like a scalene trapezoid. It uses the same names as a triangle. So that'd be a scalene trapezoid. And if I have right angles, then you have a right trapezoid. So there's a right trapezoid, scalene trapezoid, isosceles trapezoid. Notice consecutive angles here create 180 degrees because these are parallel lines cut by a transversal, which is the side. So that's 117 plus 63 is 180. So a top angle and a bottom angle would add up to 180. When you get an isosceles trapezoid, the base angles are congruent to each other. And finally, this middle segment here, that's called the mid-segment. And that is the average of the top and the bottom. So you see you have 4 plus 2 is 6 plus 2 is 8. So 6 is the average of 4 and 8. 4 plus 8 divided by 2. 4 plus 8 is 12. 12 divided by 2 is 6. Okay, if I do this, 6 plus 8 is 14. 14 divided by 2 is 7. So the mid-segment is always the average of the top and the bottom. So a few things with the trapezoids before we go look at the kites. Page 217 in your student journal. A trapezoid has exactly one set of parallel sides. Exactly one set of parallel sides. Okay. The bases. There are two of them. So that is the two sides that are parallel. Two sides that are parallel. And base angles, we say consecutive angles on the same base. Consecutive angles on the same base. So before we get too much farther in here, let's draw a trapezoid. I'm going to draw a scalene trapezoid. So the top and bottom in this case are going to be my parallel sides. I'm going to refer to the top as base 1. That's the first base. Use a subscript there. The bottom is base 2. And those are just referred to as the bases. The base 1, base 2. These would be the legs, leg, and legs. That's the next thing here. So it's the non-parallel sides of a trapezoid. Non-parallel sides of a trapezoid. Base angles. Got the base angles. So here, these two would be considered base angles. Not necessarily congruent to each other. There's a base angle, there's a base angle. And then these two up here would be base angles. Okay? So base angles on top, those would be referred to as another base angle. And if you take a green angle and you add a red angle, that should equal 180. Okay, so like a top and a bottom, that should add up to 180. Isosceles trapezoid, that is when the black. When the legs are the same length. It's a nice isosceles trapezoid, when the legs are the same length. So I could draw an example of that. Kind of like an isosceles triangle, congruent legs. Okay, those legs would be the same length. Top is parallel to the bottom. So that would be an isosceles trapezoid. Now what also is important when you have an isosceles trapezoid is then your base angles are congruent. Those two would be congruent, those two would be congruent. And they would be the same thing. So isosceles trapezoids creates congruent base angles just like in an isosceles triangle. The mid-segment of a trapezoid, okay? There's that word mid-segment again. It connects the midpoints. So the mid-segment connects the midpoints of the two legs. Connects the midpoints of the two legs. And its length is the average of the two bases. Its length is the average of the two bases. We're running out of room here for the kite, but so we have another trapezoid here. I need a midpoint over here and a midpoint over here. So that means that equals that. Okay, so it's my midpoint of that leg. That equals that. They don't have to be the same length. That is your mid-segment. Okay, it goes right through the middle there. And its length, let's say L equals base 1 plus base 2 divided by 2. That's a formula you can use if you're given the two bases, or if you're given a base in the mid-segment. You can use that if you need it to figure out the different dimensions that we'll have. Okay, so for a kite, where's my kite? There's my kite. Okay, so this is a kite. What you have here is 3.74. You have two consecutive sides that are the same length, but opposite sides are not the same length. So to have a kite, you need two sides the same, but opposite sides are not the same. Now you can see a lot of different relationships that are showing up here with the diagonals. First of all, on these two non-consecutive sides, opposite angles are congruent. Okay. This diagonal here goes down the main part. So the diagonal that splits the consecutive sides, that is an angle bisector. You kind of see the right triangle, or the isosceles triangles that are formed there. So you have an angle bisector going there, and the diagonals are perpendicular to each other. So that's what's unique about the angles and the sides. Diagonals are perpendicular to each other. The main diagonal going down the main part here is an angle bisector. Opposite angles that are of the non-congruent sides are going to be congruent to each other. Okay, the angle measures are. Okay, so for kite, what we're just going to put is two pairs of consecutive sides are the same length. Two pairs of consecutive sides are the same length. Opposite sides are not the same length. Opposite sides are not the same length. Okay? So you basically get to draw a kite. Consecutive sides are the same length, opposite sides are not the same length, but they could be the same there. Okay, so here comes all our theorems and rules that I've kind of touched on already. If a trapezoid is isosceles, then each pair of base angles is congruent. So A plus D, so angle congruent, angle A is congruent to angle D, angle B is congruent to angle C. So given a trapezoid that is isosceles, let's say this is 60 degrees. Given that, you can find the rest of them. Okay, if this is 60 degrees, this has to be 60 degrees. Now remember, consecutive angles here have to be supplementary. So if this is 160, 180 minus 60 gives me 120. Don't be going out on me black now. That's 120. And that makes that 120. So that's where your congruent angles are. The two on top, two on bottom. Okay, remember top plus bottom equals 180. They're supplementary angles. Isosceles trapezoid base angles converse. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So that's just the converse of the original statement. It takes the conclusion, moves it into hypothesis. So if you do have congruent base angles, you know for sure you will have an isosceles trapezoid. So it works both ways. You can write a biconditional statement. If a trapezoid has a pair of congruent base angles, if and only if, it is an isosceles trapezoid. Or a trapezoid is isosceles even if and only if its base angles are congruent. Okay, here's the diagonals of a trapezoid. Isosceles trapezoid, if and only if, there's that if and only if, a trapezoid is isosceles, if and only if, its diagonals are congruent. So it gave us the biconditional, so we don't have to have a theorem and its converse. Okay, so the diagonals are the same length. So they are the same length in isosceles trapezoid. Okay, so if BD is 8, CA has to be 8. Diagonals are the same length. Here's the formula. They're talking about the mid-segment theorem. A mid-segment of a trapezoid is parallel to each base. I haven't mentioned that yet, but it's parallel to each base. So you see the parallel symbol. And its length is 1/2 the sum of the lengths of the bases. So we know that as the average of the bases. The average of the bases. You can kind of use some common sense a little bit with this, that the difference between the top and the middle is going to be the same as from the middle to the bottom. Okay, so let's say this is 50 and this is 60. We know those two. Okay, DC then has to equal 70 because it's 50 plus 10 is 60. 60 plus 10 would have to be 70. That would put 60 in the middle. Okay, so it's the average of the bases. So the mid-segment length equals top plus bottom divided by 2. Diagonals of a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so there's that 90-degree angle. Quadrilateral is a kite, then AC is perpendicular to BD. Okay. Other things we talked about there is this right here is going to be an angle bisector, along with that one right there. Okay, so those are angle bisectors. The other thing, if this point right here, where that perpendicular thing, where the perpendicular sign, where they intersect, this is the midpoint of CA. That is the midpoint of CA. So a lot of things happen with these kites. So if that's the midpoint, that means we do have an isosceles triangle. CBA is an isosceles triangle. Creates some more properties for us to work with on that. Okay, kite opposite angles theorem. The quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Okay, so B is not congruent to D. That's what it's saying here. B is not congruent to D. It has to be the two angles that are between the non-congruent sides. Okay, so the two angles that are formed, by the non-congruent sides are the same measure. The two angles that are formed by the non-congruent sides are the same measure. Okay, let's get to some of this practice here. So, extra practice, page 219, show that the quadrilateral with vertices at 0, 3, 0, 6, negative 6, 0, and negative 3, 0 is a trapezoid. So in order to show something's a trapezoid, we look back at the definition. A trapezoid has to have one set of opposite sides parallel. So we're just going to draw this. And let's see, x values go from negative 6 to negative 3 to 0. We don't need a whole lot of room for the x. We need it more on the left side. Oops. Ink's running out on some of these. Okay, and y values 3, 6, 0, 0. So I'll put my x-axis a little bit lower here. And then we have 0, 3. There's Q. 0, 6. There's R, negative 6, 0. There's S, and negative 3, 0. There's T. Alright, so there's our trapezoid. Decide whether the trapezoid is isosceles, find the length of the midsegment of the trapezoid. So show that the quadrilateral with those vertices is a trapezoid. Okay? So since we have to show they're parallel, when we show they're parallel, we show that the slopes are the same. So this is going up 1 over 1, up 1 over 1, up 1 over 1. And this is doing the same thing. So both slopes have both lines have a slope of 1. So since both SR and TQ have a slope of 1, they are parallel. Okay. So we have one set of opposite sides parallel. RQ is clearly not parallel to ST. Decide whether the trapezoid is isosceles. Are the legs the same length? So we want to know about the leg length. Are those legs the same length? So ST equals a length of 1, 2, 3. RQ equals a length of 1, 2, 3. So since the legs have the same length, it is isosceles. So yes, it is isosceles. Isosceles, we're looking at the legs there. Then find the length of the midsegment of the trapezoid. Now we can use our formula to find the length of the bases and then find the average of the two. That's going to create a little bit more work. Let's find the midpoints. Right there and right there. There's my midpoints. So there's my midsegment. Okay? I want to find the length of that line. Since I'm on the coordinate plane, let's just use the Pythagorean theorem with that. So this is at 1, 2, 3, 4.5. So what I have here is basically a 4.5 by 4.5 triangle. So if I want to find that length, the distance would be the square root of 4.5 squared plus 4.5 squared. So square root 4.5 squared plus 4.5 squared. and that's about 6.36. If they want the exact value with square roots, you can use one of the blue calculators or Casio calculator and get that as well. 6.36. Okay, in exercises 2 and 3, find the measure of angle K and measure of angle L. So here we have a trapezoid because we have one set of parallel sides. Legs are congruent. That means base angles have to be congruent. So if this is 23, that has to be 23. So the measure of angle L has to be 23 degrees because of the base angles. K, remember a top and a bottom. If you think of this like this, okay, the top and the bottom have to be add up to 180. So the measure of angle K, I have to take 180 minus 23. 180 minus 20 is 160, minus 3 would be 157. So L is 23, K is 157. Okay, we have a kite here. We have a kite. And we know that the measure of angle L has to equal the measure of angle K. They are the opposite angles that would be congruent. Okay, because they're formed by the non-congruent sides. So all together, these have to add up to 360. So I'm going to take 360, I'm going to minus the 130, and then I'm going to minus the 90 for the two angles there, and I'm going to divide that by 2. So 360 minus 130 is 230, minus 90 would be 140. 140 divided by 2 equals 70. So both of these should equal 70 degrees. And you can check your answer. 90 plus 70 plus 70 plus 130. Okay, 360. Here we're checking the mid segment. Find the length of CD. So it's the average of these two right here. So you just take 12 plus 36 divided by 2. So that's 48 divided by 2, which is 24. So CD is 24. CD now is the bottom side. So 0.6 to 1.8. How I would do this is I would just say, okay, 1.8 minus 0.6 is 1.2. So the distance between these is 1.2. That's the distance. This distance also has to be 1.2. So if I would take 1.8 plus 1.2, I get 3. So CD has to be 3 in that case. You can use a formula. I'd rather use a little bit of this, just knowing the distance is the same between both of them. When we have variables all over like this, now we have to use a formula. This, x plus 11, plus 3x plus 3, we're going to put those together, divided by 2 has to equal 3x minus 2. Now the first thing we do here is this 2 multiplies to this side. So we're going to take both of those times 2. I'm going to combine this left side as well. X plus 3x is 4x, so 4x plus 14, that went to that, has to equal 6x minus 4. So minus the 4x over, add the 4, so 2x equals 18, x equals 9. So x equals 9, that's what they want. You can plug it in and they should equal that. That would be 20. This would be 25, and this would be 30. So that would all work out. It's all the same distance. Okay, finding the value of x, remember J is the midpoint of this cross piece. So 9 has to equal 1/10 x minus 1. So add the 1 over, 10 equals 1/10 x. Multiply both sides by 10. That basically cancels that side off. We're multiplying that 10 over. So x equals 100. You'd have that done like that. Okay, there's a lot of other applications with this. You'll see some of those questions as you go through the assignment. Feel free to ask as they pop up if you're having trouble with that. But try to do it on your own. Try to work on it. And remember our properties and all of the different things that apply with the diagonals and the angles for the trapezoids and kites. But good work, and we'll see you in class.